Yeah, hi everyone. This is a graph in my basic algebra series about plotting linear graphs. I'm going to show you 3 different ways we can plot them, and then talk about a few special cases. So there's quite a lot in this video, so I'll go pretty quick, so make sure you pause it and rewind it if you need to. Okay, we're going to start with plotting graphs, linear graphs, by plotting a table of points. They probably did this about grade 7, so we get the equation y equals x. That means you pick a value for x and the value for y will be the same. And then you put those points, so -2, -2, you put all those points on your graph. And then this is a line, so we join up all the points. So y equals x is true for these 4 points, but it's actually true for every point along that line. So there's infinite number of points along there. Okay, y equals 2x. So you pick some values for x, work out what y would be, so by multiplying by 2, and then plot those points on your graph and join them up. So y equals 2x at those 4 points, but at every point on that line. That's the line y equals 2x. Y equals 2x plus 1. Again, you pick some random points for x, put it in the formula, work out what y is, plot those points, and join the dots. Sorry, a bit fast. One more. You pick some random points for x, you put that in your formula and work out what y is, plot the points and join them up. Now in those 4 examples, I did 4 points each time. Actually, you don't need 4 points. 2 points is enough to draw a straight line. It's often good to do a couple more and doesn't take you long to just check you're right and make sure you got it 100% accurate. Okay, so that's the most basic method. Next method is by plotting the x and y intercepts. So we've got a different form of the equation here. What we do is we say when x equals 0, what does y equal? Well, x equals 0 is here, but all along this blue axis here, along this y-axis. So when we put x equals 0 in our formula, we work out that y equals 2. So we can put a point at 0, 2. Then we make y equals 0. Put that in our formula, or our equation, sorry, and you get 2x equals 6, x equals 3. So 3, 0 is where it crosses the x-axis. And then you join them up. So this equation works at those 2 points, but it works at every single point along that line. So if you take any of these coordinates along this line and put them into this equation, you will get an answer of 6. That's the idea. Okay, another example. You've got an equation here. You put x equals 0, and you work out where it crosses the y-axis. You put y equals 0, and solve it, work out where it crosses the x-axis, and you join up the dots. Okay, one more. You put x equals 0, work out the y-intercept, where it crosses the y-axis. You put y equals 0, work out the x-intercept, where it crosses the x-axis. You put the 2 points, you join the dots, and keep the line going. Okay, so you just need the 2 points. The simplest 2 points to find are when x equals 0 and y equals 0. Only trouble you have is if it goes through 0, 0, then you can't use this method. Right, so the next method is by the gradient intercept method, or the slope intercept method. If you don't really understand gradient and slope, I've got another video you can watch on that. So we've got the equation in this format, y equals mx plus c. Okay, so y equals something x plus something. This plus 1 here means the y-intercept is 1. Or if you use the method we did before, we put x equals 0, so the 2x disappears. So you get y equals 1. So that's easy to find. Now this 2 is the gradient. So that means 2 means 2 over 1. And remembering gradient means rise over run, means you rise up 2, run 1, put another point. Then you join those two dots. So just again, gradient means change in y over change in x. So you go up 2 across 1. So if we started there, we'd go up 2 across 1 as well. So you can check that everything's going at this angle. 1, 2, 1, 2, 1, 2. Okay? Sorry, I should have said 2, 1, 2, 1, 2, 1. Right, let's do another one. So this time y equals negative x plus 3. So plus 3 is your y-intercept, so you put a point right there. And then negative 1 as our gradient means negative 1 over 1. So you do a rise of negative 1, so go down 1, and run of 1, so you go across 1. Put another point and join the dots. And just make sure as you go along that it's down 1 across 1, down 1 across 1. Okay? Next one, y equals 3x minus 4. Minus 4 is our y-intercept, so you put a dot there. 3 is 3 over 1, so you go up 3, across 1, put another dot. And you do the same again. Now this line's not quite perfect because I should go up 3 across 1 and it should go through that point right there. So it's not bad, but it's not perfect. So I should have done a bit better than that. There, I'm happy now. Up 3 across 1. Okay. Last one. You got y equals 1.5x minus 1. So minus 1 is a y-intercept, put a dot there. 1.5 is 3 over 2. So you go up 3 across 2, and put another dot, and then join them up. You go up 1.5 across 1 to get there, or this from here you go up 3 across 2, so that line looks really good. Okay, so that's the slope-intercept method, gradient-intercept method. A couple of things about horizontal and vertical lines. What do these points have in common? Their y-coordinate is all the same. So at each of those points, and at every point on that line, y equals 2. So if you see a horizontal line, it'll have the equation y equals 2. Also remember that 2 is its y-intercept, and its gradient is 0, so it's like y equals 0x plus 2. So any horizontal line has the equation y equals a constant, and it'll be wherever it crosses the y-axis there. Similarly, what do these points have in common? Well, all their x-coordinates are 3. So that is the line x equals 3. So any vertical line has the equation x equals whatever its x-intercept is. So obviously there's two important lines to talk about. X equals 0 and y equals 0, which are our axes. So x equals 0 is the y-axis, y equals 0 is the x-axis. When you understand where it comes from and what it means, it makes sense. But you can also kind of remember it's the opposite. Y equals 0 is the x equals 0 is the y. Okay, parallel and perpendicular lines. Parallel lines, here's an example. If we work out their two gradients, you see their gradients are the same. That suggests that all parallel lines have the same gradient. Here's another example, and you can tell that from their equations as well. 2x, 2x. Another example, working out the gradient from those points. They have the same gradient, so they're parallel. Okay, perpendicular lines. Perpendicular means they're at 90 degrees to each other, so these angles in here are 90 degrees. If we work out their gradients, the pink one is 8 over 4, 2. The red one is minus 4 over 8, which is a negative a half. So 2 is 2 over 1. This is negative 1 over 2. So we call that negative reciprocals. Okay, 2 over 1, flip it over, you get 1 over 2, make it negative, negative 1 over 2. The other way you can think about it is if you multiplied those two numbers together, you'd get negative 1. So if you multiply the two gradients together and get negative 1, they're perpendicular. There's their equations. This one, same thing, get the gradients. This one's a bit easier to see, negative 3 over 2, 2 over 3. So they're flipped over fractions. This one's negative, this one's positive, so they're negative reciprocals. Or if you multiply them together, you get negative 1. So if you have lines with gradients that are negative reciprocal, they're going to be perpendicular. Okay, that was a lot of information in that video. Go back and watch any parts you need to, and good luck with plotting graphs. It's a really important skill, and you'll be asked to do it for a lot of years to come. So good luck with the questions you encounter.